So today we're going to look at values not on the unit circle. And in order to evaluate the trig functions, we're going to make use of our right triangle trig. So thinking about SOHCAHTOA. So values not on the unit circle. So if I have a point on the terminal side of an angle in standard position, we're going to find the exact values of each of the 6 trig functions given the point x and y. So if I think about a positive x and a positive y, that would put me in my first quadrant, and here would be my right triangle representation of that. So here's my theta, here's my x distance, my y distance, and that gets me to the point xy. And we're going to call our hypotenuse r. So SOHCAHTOA, right? The opposite side over the hypotenuse would give me y over r. Cosine adjacent over hypotenuse, x over r. Tangent would be opposite over adjacent. And then I have my reciprocal. So cosecant would be the reciprocal of sine. Secant, the reciprocal of cosine. And then cotangent is the reciprocal of tangent. Now, sometimes when we're not given one of the trig functions, okay, we're just given the ordered pair, we're going to have to use the Pythagorean theorem. Okay, and instead of a, b, and c, we're going to use x, y, and r. So that would look like x squared plus y squared equals r squared. Now, we also want to make sure that we are identifying the correct quadrant, right? Because that gives me the sign of x and y, okay? And to help us do that, we're always going to start by drawing a reference triangle in the correct quadrant so that we can see exactly what we're looking at. So let's look at an example here. So I have the ordered pair 3, 4. So I have a positive x and a positive y. That's going to put me in quadrant 1. Okay, so drawing a quick triangle in quadrant 1. Here would be my point 3, 4. So that would be 3 in the x direction, 4 in the y direction. And I don't know what r is. So using the Pythagorean theorem, I would have 3 squared plus 4 squared equals r squared. That would give me 9 plus 16. And then I would square root both sides. Now, usually when we square root both sides, we have to take into account the plus or minus, right? And if you're finding the x or the y by square rooting, you do have to take that into account. And we'll look at an example of that in a little bit. But my hypotenuse is always going to be a positive number, okay? So r is always going to be positive. Now, just to kind of put all of our info in one spot to make things a little easier, I know that the x is 3, the y is 4, and then I just found that the r is 5. Okay, and if you remember back to your geometry days, this is a special right triangle, right? This is a 3, 4, 5 right triangle. So finding my 6 trig functions, I would have sine of theta, which would be y over r, so 4/5. Cosine would be x over r, so 3/5. And then tangent would be y over x, which would give me 4/3. Now the reciprocals, cosecant, flip sine, so I would have 5/4. Secant would be 5/3. And then cotangent would be 3/4. Okay. Now, the second one here, I'm not going to do the whole problem. If you want to pause and practice this, you can do that. The answer key is posted on Schoology, so you can check your work. It's very similar to the one we just did. It's just that here I have a negative x and a negative y. So that would put me down in quadrant 3. Okay. So go ahead and practice that one if you want. We're going to look at this next one here. So this one's a little bit different. So again, start by figuring out the quadrant in my triangle. So I have negative x, positive y. So that's going to put me in quadrant 2. So I would have negative 1, here's theta, and then positive 2 in the y direction. And I need to find r. So again, using the Pythagorean theorem, negative 1 squared plus 2 squared equals r squared. So I get 1 plus 4. So r is going to be the square root of 5. So x is negative 1, y is 2, and r is the positive square root of 5. So since my hypotenuse has that radical sign in it, when I go and set up some of these, I'm going to have to rationalize my denominators. So when I look at sine is y over r. So that would give me 2 over the square root of 5. But again, I can't have those radicals in my denominator, so I would have to rationalize and multiply the top and bottom by the square root of 5. So I would have 2 root 5 over 5. Okay. Cosine. I would have negative 1 over the square root of 5. Again, rationalizing. Multiply top and bottom by the square root of 5, and I would get negative root 5 over 5. Tangent, y over x, not going to involve a radical, so that makes this a little bit nicer. So I would have 2 over negative 1, which would just be negative 2. Now, to get the reciprocal of these, I want to look at what I set up before I rationalized. So I have the 2 over the square root of 5. So taking the reciprocal of that, I would have the square root of 5 over 2. Again, looking at, for secant, looking at the cosine before I rationalized, I have negative 1 over the square root of 5. So flipping that fraction, I would have the square root of 5 over negative 1, which would just be negative square root of 5. And then negative 2 over 1 would become negative 1 over 2. All right. Again, I'm not going to do the second one here. It's very similar to the one we just did, so if you want to pause and practice it, you can. Here we have a positive x and a negative y, so that's going to put me in quadrant 4. Just to set up the triangle for you all who want to try it. There's theta, positive 4, negative 6, and then you would find r. It would give you a radical, and you'd have to rationalize, okay? So again, try that on your own if you'd like. Check your answer with the answer key on Schoology. All right, now, you're not always going to be given an ordered pair. Sometimes you're going to be given some of the actual answers to some of the trig functions. So we're going to kind of work backwards here to identify x, y, and r. And then from there, I'll find the answer to the remaining trig functions that I don't have. So looking at what this gives me. So it gives me sine and cosine. So remember, sine is y over r. So from the sine theta, that answer it has, I know that y is 2 root 5 and r is 5. And again, remember, r is always going to be positive. So if there's ever negatives, like with the cosine, it's going to go at the top. And cosine is x over r. So I know my x value is negative square root of 5. And again, r should be the same. R is 5. So I have a negative x and a positive y. So that's going to put me in quadrant 2. So I have negative square root of 5 for the x, 2 root 5 for the y, and I need to... All right, so now that I know what x, y, and r all equal, I can find the remaining trig functions that I don't have. So tangent would be y over x. So that would be 2 root 5 over negative root 5. So the square roots would cancel, and I would be left with negative 2. Doing my reciprocals, flipping my fraction here, I would have 5 over 2 root 5, and then rationalizing, I would have 5 root 5 over 2 times 5. The 5s would cancel, and I would have the square root of 5 over 2. Secant, negative 5 over the square root of 5, and then rationalize. Again, multiply top and bottom by the square root of 5. Get negative 5 root 5 over 5. 5s would cancel, and I'm left with negative root 5. And the reciprocal of negative 2, you can do it that way, or do the fraction here flipped, and then again the square roots would cancel and you'd be left with negative 1/2. Here is another one, again very similar. It gives me the y, the r is 3, and the x is negative 1. So negative x, negative y would be quadrant 3. And then you guys can pause and practice this if you'd like. Again, check the answer key to make sure you got it correct. Now, the last problem type we're going to talk about is when you are given one of the trig function answers and another piece of info. Okay, and that piece of info will help us figure out what quadrant we're in. And then once we know that, we can find the missing piece by using the Pythagorean theorem. So let's first start by breaking down the trig function it gives me. So it gives me sine of theta equals negative 2 over 3. So that means that the y is negative 2 and the r is 3. And I don't know what x is, so I'm going to have to find the x using the Pythagorean theorem. So x squared plus 4 equals 9. Subtract the 4 over, and then square root. Now, because this is not the hypotenuse, okay, remember I said earlier when you're finding the x or the y by square rooting, there is a possibility that this is positive or negative, okay? And that's where the second piece of information is going to come into play. Okay, I have to figure out what quadrant I'm in to figure out what the sign's going to be for that x value. So I know that y is negative. Okay, so that's going to put me in quadrant 3 or 4. But then I look here. Okay, and that tells me that my theta is between pi and 3 pi over 2. So if you think about the unit circle, here's pi, here's 3 pi over 2. So that means I'm going in quadrant 3. So here's theta. I have the negative y, and that means that I'm going to have the negative square root of 5 here. So negative square root of 5. And then I just need to find my remaining trig functions. So x over r, negative square root of 5 over 3. Y over x, so negative 2 over negative root 5. The negatives would become positive, and then rationalizing, I would get 2 root 5 over 5. My reciprocals, so cosecant would be negative 3 over 2. Secant would be negative 3 over the square root of 5. Rationalize, 3 root 5 over 5. Cotangent, negative root 5 over negative 2. So I just would have positive root 5 over 2. And, sorry, this is 3, like we talked about. Okay. So again, here's another one, very similar. This time it gives you cotangent, and that sine is less than 0. Okay, so identify the pieces it gives you. Take into account what sine less than 0 means. Okay, that tells you something about your y values. set up your triangle, find the missing piece, and then find your remaining trig functions. Again, practice that if you want, and check out the answer key to make sure you got it correct.